Okay, one thing I have to clarify about this space elevator design that I'm working on is that it would need to be anchored at geosynchronous orbit or geostationary orbit. I can't remember which one this is exactly. So we would still need eventually, or really ultimately, or really to have it completed, this 36,000 kilometer bit of cable or so up in space, anchored to a counterweight, and yeah, and then we still have the problems of this this issue that we don't have any materials that strong. All right, we don't have any materials capable of taking the tension on the cable. I don't think anyone still has had the idea. My idea still works, of course. This idea is still valid. I think this idea of just releasing tension on the cable by pushing the station or whatever you have at the other end back towards Earth slightly and making it slack in that way. I think we can probably in stages make it out of Kevlar and so on. But like the stages in space would probably have to be like 100 kilometers each, and we would need a space elevator, I think, in space. Do we have really? Do we really have rockets that are capable of launching? Like, wasn't necessarily like kind of a small space station each time, because you're still going to need to have, well, I guess like motors and things on it if it's an elevator. With the climber on it, if you want to have that still, and not just have an anchor up there and just a very long bit of cable attached to a counterweight out at geosynchronous orbit. And then I start thinking, like, is this thing even worth building? Because we're not going to be launching 36,000 kilometers of cable anytime soon. I think it's conceivable, though, if we've got something reaching above the Kármán line, and whatever, like we could get above the Kármán line. We still need rockets to get it anywhere further than that, which is, but it's a big advantage getting something up there at least, isn't it? It's like, it makes things a lot easier. It makes launching a rocket easier. Like, the most difficult bit of, launching a rocket is really getting off the launch pad, like where gravity's the greatest, in any case, we stand to gain a lot from a space elevator, and then like when everything's in the atmosphere, as picturing, like the jet engines and rocket engines pointed downwards, but like obviously, upwards even, generating downwards thrust, again relieving tension on that cable, but but obviously, during the construction of the space elevator, those rockets will need to be firing constantly, like all the time, up to the Kármán line. Then I was thinking, at the Kármán line, we can lift something up the space elevator that's going to act as the space station, construct a small space station up there at the Kármán line, drop an anchor, out to geostationary orbit with a counterweight attached to it. That would be the thing to do. So I was missing that as well. Or I wasn't stressing that about a space elevator. We can build something at the Kármán line. We can ship payloads up there to maybe be like magnetically, like railgun style propelled out into the solar system, or like rocketed out, rocket propelled. Or whatever we want to do. Like, I mean, I was picturing also like space planes and things, maybe even. And things will move very quickly, I think, from the Kármán line out to geostationary orbit. So, you say 36,000 kilometers. Oh, this will take ages to get anywhere. Well, yes and no. Well, no, not really. Well, because it's going like, I don't know how fast things actually move in space. It's some amount. It's always in meters per second, though. So it's always very quick. That's what things go in space. So it's two different worlds of physics that have to marry one another, isn't it? We have to get like out of our physics within the atmosphere, out of our atmospheric physics into space physics, and having a structure that's capable of bridging that gap between those two worlds. So it does need but it's not as simple as just dropping a fucking cable from sea level. The design can't be that simple, now can it? It's got to be a bit more sophisticated than that. You want an elevator, and it's got to have engines. Very sorry, you're going to have to burn some fuel. Sorry. I don't think there's going to be any way around that. You have to burn some fuel, get some serious ion thrusters on various points, probably on the design, I'd have imagined. And, why is construction going that way and the other construction going that way? It will be a rocket-propelled building. Think of that. What an amazing machine. Like, what a mad idea. It's that sort of thing a fucking mad scientist would think of, isn't it? Like an electric snake. Like, that's a weird, like, flailing power cable dangling in the atmosphere. Riding on it, like, it'd be quite a fucking ride up there. Like, with the winds high in the atmosphere, like the 250-mile-an-hour jet stream winds. And, and the bits where, like, your tears boil. Up in the mesosphere. Like, I don't know all that much about the mesosphere, actually. I just know the air. I know the atmosphere is very thin, and like you need a pressure suit because your tears will boil if you don't have one. I found myself laughing an inordinate amount thinking about this. But as I said before, I think, like, okay, so the easiest part of it by far is getting to 150,000 feet or so. Like, that's not so hard. I don't think. We can use balloons up to that point. Yeah, like someone figured that out. Some genius, frankly, figured out, how to hack halfway to the Kármán line. Brilliant, good stuff. I would recommend steering it with jet engines against the wind also to keep it nice and stable. That would be my little input on that one. I don't know if anyone's come up with the idea of jet engines for it, but above that, in the mesosphere, you got power of rocket engines. And once the anchor's deployed, then we can build along the cable, can't we? Going towards the counterway, send a climber along it. Yeah, it'll need to be electrified, but I mean, would it? Yeah, the device need to be electrified. We can assemble it. We could almost like build a space station that 3D prints itself. That's an evil genius idea, I think. If dare I say the G word. But anyway, so yes, something's gonna be out of geostationary. Second space station, I guess that's what the counterweight would be. So in the Earth's rotation and in its orbit around the sun, it's now got to drag a space station. But it's along 36,000 kilometers of cable, and following the same principles as the design of the space elevator in general, we still need to remove tension from the cable. Do we not? So we need to relieve tension at various points along it. So yeah, you'd have to build intervals with machines with systems of propulsion to remove tension from the cable. But like also up there, if in terms of sending things along it, by far your easiest means of propelling things around at that point is probably burning hydrogen and oxygen and just going in rockets, going in spaceships. So, however, having said that, getting things to and from space, up to the Kármán line, and then loading it into spaceships and what I'm imagining like big docking stations up there and things for starships and whatnot, and those really like do the lion's share of the heavy lifting around the solar system. This will allow us to do so. This is so worth spending the money on. It really, really is. This is unbelievably worth it. Okay, the things we could do up there, like we could do all sorts up there. Particle physics experiments, manufacturing computer chips or whatever, smelting iron, agriculture, everything I've mentioned. But we could start building the big starships that we need to send people to Mars and out to the outer solar system and Jupiter, the gas giants, ultimately to other solar systems. Big ships is what we could build up there because of space elevators, just getting it out of most of the gravity, right? You just need to think of it as a gravity gradient. So, like, yeah, it's counterbalanced at geostationary orbit, but but actually, like, most of the gravity is diminished. You see, so and then beyond that, you get the centrifugal force that drag the blow attention to the cable that we then need to relieve. But yeah, like sending things there though from the Kármán line is a lot easier than from the surface of the planet in terms of like propellant weight and things. So it's of course worth doing. This is certainly worth doing. You think like, oh, I'll spend a lot of money on fuel. It won't really. Like just the jet engines on the dirigibles, like those will be firing a little bit just to correct it mostly. It's a lot less fuel than rockets. But this is so what we want. If you want like a Star Trek style future, I think as opposed to no future, as opposed to the future of self-destruction. I remember saying, yeah, I do agree with Elon Musk. I think we need to colonize Mars. I think he's right on that. But yeah, yeah, I'm sorry. This is the big problem with Space Elevator. It was just, it needed something else. It needed an additional layer of sophistication to it. It'll probably need other layers of sophistication to it in the future if I'm being realistic, I think. But yeah, it was missing engines. It's missing systems of propulsion. Or like Isaac Arthur mentioned, I think the YouTuber sort of said, oh, you need to put a thruster on it to do something, but didn't quite say what that something was, or I missed it, frankly. But I've never read anything about like a space elevator with engines on it. But no, you do need engines on the thing. And the idea from the high altitude, helium assisted space elevator, yeah, that's genius also. I guess that's a long way to the Kármán line, which is very helpful. So yeah, I thought I'd mention that.